All right, boys and girls, this is kind of a continuation or an extension of the first examples that I give you for synthetic division. For these examples, the question's asking you to determine whether the given binomial is a factor of the polynomial p of x. If so, find the remaining factors of p of x. Okay, that factors is kind of the key word. Okay, so here we go. So our polynomial that's given is x cubed plus 3x squared minus 4x minus 12, and our factor is x plus 3. Well, we don't know if it's quite a factor, but we're going to check if it's a factor. Okay, so basically our setup is going to look like this. Remember, if we're given x plus 3, we should put negative 3 in here. And then let's write down all of our coefficients. So we should have 1, 3, negative 4, and negative 12. Notice every single degree is given in descending order. So 3, 2, 1, 0. They're all there. So we don't have to put any placeholders in this case. Okay? And now we just go through synthetic division. So our first value, we just write it down. So this is just 1. Then we multiply 1 times negative 3, and we get negative 3. 3 minus 3, we're combining like terms, we get 0. 0 times negative 3, 0. Combine like terms, negative 4 plus 0, negative 4. Negative 4 times negative 3, positive 12. And if we combine like terms, that's 0. Remember what I had previously said? Our very last value is always going to be our remainder. But in this case, since it's 0, we don't have any remainders. What that means, that x plus 3 is a perfect factor. It goes in evenly, okay? So now how do we write our polynomial? This is degree 3, so this has to be degree 2. So we're going to write x squared. Then this would be x, but there's no x. So then we just write minus 4, okay? Since they're looking for the factors, okay, technically this is the factor and so is x plus 3. But now you're going to practice what you've learned, okay? Now you're going to factor this out. So remember, you previously learned that this is the difference of two squares. So I can factor this out as x plus 2 and x minus 2, okay? So these are the factors including x plus 3. So our final answer is x plus 3 times x plus 2 times x minus 2. So we found our solutions. Okay, these are all the factors. And there's no remainder, so I don't need to add or subtract anything. And that's it. Okay? All right, let's do another one like this. Okay, so the directions are the same. So our polynomial is x to the fourth minus 4x cubed minus 6x squared plus 4x plus 5. So it's a little bit of a long one. And we're going to check if x plus 1 is a factor. So again, when I set it up, remember if x plus 1 is a factor, we should have negative 1 in the box. And then we're just going to write down our coefficients. So ready? 1, negative 4, negative 6, 4, and 5. Okay? And then here we go. Again, bring the first value down. So that's 1. Multiply 1 times negative 1, negative 1. Combine like terms, negative 5. Multiply negative 5 times negative 1, positive 5. Combine like terms, so negative 6 plus 5, negative 1. Multiply negative 1 times negative 1, so positive 1. Combine like terms, 4 plus 1, 5. 5 times negative 1, negative 5. Combine like terms, we get 0. Whenever you get 0, that's always a good sign. That means it does go in evenly. Okay, so here we go. Ready? Our factors should be x cubed minus 5x squared minus x plus 5. And don't forget, x plus 1 was also a solution. Now, I would say leave it like this, but you guys know we can't leave it like this because they want factors. So what we have to do is we have to factor this out, okay? So again, you're going to use what you've learned. So if you factor that out, basically there's 1, 2, 3, 4 terms. Remember, whenever there's 4 terms, you want to factor by grouping. So let's do that. Okay, so I should have x cubed minus 5x squared. And then I'm going to put plus negative x plus 5. Okay. And then in the first grouping, I can factor out an x squared. So I'm left with x minus 5. And then these need to look the same. So what I can factor out is a minus 1. And if I do that, we have x minus 5. So now they're the same, see? And so remember, when they're the same, we group the greatest common factors. So I'm running out of room there, so I'm just going to write it to the side. So now we should have x squared minus 1 and x minus 5. So those are our factors of that, okay? That's our factor. So our solution should be x squared minus 1 times x minus 5. But you'll notice something. You can still factor x squared minus 1 because there's the difference of two squares. So let's do that. Okay, so I had to get a new whiteboard because I ran out of room. So remember, this was our first divisor to begin with. These were our factors, but this is the difference of two squares. So we should get x plus 1 and x minus 1. Okay, and then I'm just going to bring these down. So x plus 1 and then x minus 5.